Good evening, everyone. Welcome to Sustainable Ramona, the second offering in our symposium series, the first being on water conservation, and the next on transportation in a month or two. Later on this week, we'll be having 4 other speakers. Tuesday, we'll have Steve Way. He lives in Ramona, and his presentation will cover the mandatory recycling ordinance in the unincorporated county of San Diego. He'll cover paper and cardboard, plastics, glass, and metals, as well as organics, recycling food scraps, food foil papers, and yard trimmings. On Wednesday, we'll have Robert Carr and Tom Abram. They'll be speaking about building electrification, energy audits analysis, climate action planning, sustainability management, decarbonization, electrification, and green building design, and advocating for just, equitable, and sustainable communities for all. And Thursday, we'll have Drew Hubble. He will be talking about reusing existing structures. He specializes in sustainable architecture, green building materials, and the use of alternative building materials such as straw bales, insulated concrete forms, adobe, and sprayed concrete construction. So tonight we'll be looking at an overview of sustainable homes and energy efficient design. We'll get into new ground up projects with different styles and techniques for obtaining energy efficiency. We'll touch on commercial buildings and then go over some ideas for greening up an existing residence. I'll be covering a lot of ground tonight in a short period, so if you see something that looks interesting, grab a screenshot of it. We'll be recording this series as we do them all, and we'll post them on the website. I'll go fairly quickly, so we'll have time at the end for Q&A. So please make a note of something if you want to go over it then, or use the chat feature. So let's get started. This is the overview of sustainable homes and energy efficient design. This first part will be on energy efficient residential new structures. In selecting a building site, keep in mind a south-facing slope for house orientation for wind and solar availabilities, and of course, views. Wood frame construction is the standard most common type in the US. It's less expensive, most standardized method. It uses trees, although most of our construction lumber now comes from fast-growth forest. Steel frame is basically the same, except you use screws instead of nails. The pros are these are better in fires, better for pest damage, but it's much more expensive since it's not widely used in the residential arena. And steel manufacturing is not a climate-friendly process. Straw bale construction has been gaining popularity recently. Drew will cover this in depth on Thursday, but this shows you a cross-section of what a straw bale house looks like, and also finishing, putting the final coat, or at least the scratch coat on straw bales. You can see all this straw that is built out of. Insulated concrete forms are also increasing in popularity. There are several of these around the Ramona area. You form it by placing the styrofoam around the perimeter and filling it with concrete. Drew will also be covering this on Thursday to much greater detail. There's a lot of adobe houses around our area. It's been around for centuries all over the world. There are 2 different kinds. In Pueblo, the Pueblo style in northern New Mexico, and the Hacienda style is up around us here, coming north from Mexico. These homes can maintain very stable interior temperatures, especially when used with some of the other techniques that I'll describe. And also, Drew will be covering adobe more on Thursday. Here's a couple of examples of Pueblo style in Taos, New Mexico, and this one is right here in Ramona on the right, this Hacienda style. Rammed earth utilizes the earth as a structural element, and you can use on-site materials. And Drew, I'm not sure if Drew's going to be talking about this on Thursday. Then we have 3D printed homes. Everybody's probably been hearing a little bit about these, and they may become way affordable in the future. They're not super affordable yet, but as more and more designers and builders start to use them, they're much less labor intensive and they will gain in popularity. Underground or semi-subterranean construction. This type of building makes it possible to utilize the stable underground temps of the earth. And around here, it's always about 54 degrees at 6 feet deep. It makes for great free air conditioning if you can get those temps inside your house. We'll look at some other ways to do that as we go. This is an underground garage that we built, and the slides show the progress as it appears to near completion. This one has something called B-decking on top of the beams, and this shot is ready to pour a concrete slab, which will then be waterproofed. This is what it looks like once the earth is applied to the top. Sorry, I keep going backwards here. This is what it looks like inside. It's about a 900 square foot garage. This is what it looks like finished on the outside. And then on a trip to Vancouver Island in British Columbia, we took this shot, which was kind of interesting, of a sod roof with goats on top of it. These are earth ships outside of Taos, New Mexico. They're completely off the grid and a completely self-sustaining community. Used tires are a worldwide problem, and they're used in the construction of earth ships. These are some interior shots. The Earthship group is going to different countries and training folks in building these. They're extremely labor intensive, but very cheap. After the big earthquakes in Haiti, they sent a team down there, and there are several in Haiti now. This is a diagram of how an Earthship works. You have your solar gain coming in through the south-facing windows into a built-in greenhouse. Fresh air coming in from the north side, and it vents out the top. Now, Taos, New Mexico is around 8,000 feet of elevation. And if you were to build an Earthship in Ramona, you would put much more of the design criterion into keeping it cool rather than warming it in the winter. This is an Earthship under construction, and you can see all the used tires before they're covered and before they're burned up with earth. This is a cool shot of an Earthship in the winter, and that's just a really cool shot of an Earthship, period. Now we'll switch over to our next topic, which was home design using energy efficient techniques.
I don't hear anything.
You need to figure out your geometry, whether you're going to use a standard round octagonal or multi-sided unit, or use a dome or clusters of domes, which are pretty cool. I built some larger domes, and they're very expensive when you have to have so many angles applying interior walls onto a dome. Or yurts. Living in the round is one of the most healthy things that you can do. Foundation style, you would determine if you're going to have it on a slab or a raised foundation. The bulk of the properties around Ramona and most of Southern California are on slab on grade. This is an image of a multi-level home of 7 levels, and you can see three of the levels.
I don't hear anything.
Notice the porcelain tile directly applied to the slab.
There it is.
So as to utilize the slab for thermal mats. This house works very well. Your roof style and pitch, you try and get them orienting the south. And for solar panel inclination, somewhere between a 412 and 812 pitch, or 17 and 33 degrees from horizontal, is what you want. This depends on basically how the house is designed and what kind of power you're using. If you are using gas to heat in the winter, you probably want a lower pitch so that you can get more solar gain in the summertime. If you're using electric heat, you might use a steeper pitch because you're going to have greater electric needs in the winter. Solar will always have less output in the winter than it does in the summer. You always want to tilt them because solar panels will lose up to 25% of their efficiency if they're installed flat with no inclination. I'm a big believer in interior ceilings being vaulted. This allows you airflow options to allow low, cool air in from down low and vent it out up high with operable windows or vents. You would determine your window style. You want to make sure you get dual glazing as a minimum. One of the pictures I showed you of the 7-level home has triple glazed windows. They're kind of heavy to open and close, but they are very quiet. Low E is great if you have any of the windows getting direct sunlight. And argon gas is great helping the U values, and tinted if you have hot west sun hitting some of your windows. It's great to do that. Solar screens are great, especially for retrofits. They will knock out 80 or 85% of the sun's heat before it gets in the house. I always use R21 and R38 ceilings insulation in Ramona. These are three of the most important things that you can do in designing and building an energy efficient house. Optimum overhangs, and I've got a graphic here in a minute, but optimum overhangs for shading in the winter and passive solar heat gain in the summer. Radiant barrier roof sheathing is one of the most important items. It can reflect, it's on the bottom of your plywood or OSB board. It reflects up to 85 or 90% of the sun's heat before it even gets in the attic. So it makes the house much cooler. And heel trusses, I'll show you the graphic in a moment, but it allows you to have the full installation value on your exterior walls. With the optimum overhang, and this one is set up as a 3-foot overhang with an 8-foot wall and a 412 pitch roof, which is very common in the Ramona area. You can see the low winter sun coming in underneath the eave and through the window and heating the house, especially if you have a flooring material that can absorb the heat as thermal mass and give it off later. In the hot part of the summer, you'll see the eave keeps the hot sun from getting into the window. This is a picture of some scissors trusses with the heel truss. The heel truss allows 13 inches, so you have an inch of airspace and 12-inch R38 insulation. The heel truss looks like this. A regular truss comes all the way down here and scrunches all that insulation down, so all your heat goes out of the ceilings at the edges. The radiant barrier on the bottom of the plywood is right there. And it's the radiant barrier is like aluminum foil on the bottom of the sheeting. Thermal mass. I'm going to talk a little bit about thermal mass because it is so very important. Once heated up or cooled down, large amounts of built-in thermal mass will hold the interior habitable space temperatures for long periods of time. Thermal mass is the key to inside temperature stabilization. For rock or water storage bins, for both heating and cooling, rock storage bins can give off their heat and cold slowly throughout the day. Water containers, I've used 55-gallon drums right behind south-facing glazing. And the glass holds about 50% as much storage as rocks or solid masonry as thermal mass. Large exposed rocks, as you see in the photograph here, are great depending on what you've got on your building site. They get kind of expensive if you're trying to import huge boulders, but you can design large boulders into your plans. This one was naturally on the site and the home was designed around it. These really help to keep the inside temperature extremely stable all the time. Vertical concrete. This can be in the form of cement-filled concrete blocks or formed and poured in place concrete vertical walls. These keep temps very stable, especially when combined with semi-subterranean and underground designs. Adobe and brick. Adobe walls are generally about 16 inches thick and provide tremendous amount of thermal mass. Adobe homes are known for staying very cool during the summer. They'll get chilly in the winter unless you insulate heavily and have at least dual glazed windows and glass doors, and use some of the other techniques I'm talking about tonight. Concrete block walls. We've designed and built 2x enclosures around the perimeter about 6 feet out from the exterior of the block and insulated with R21 bats, thus insulating the thermal mass of the block from the outside fluctuating temperatures. You also need to upgrade the windows and roof insulation system. This creates one of the most efficient living systems available from an energy dog of a former block house for refurbs. Floor cover. For thermal mass over slab foundations, carpet, wood, and vinyl are not too great a way to go, as they insulate the slab from all that great low temperature. Porcelain tiles, stone flooring, and finished concrete surfacing is the way to go in order to get stabilized temps for a home. Thermal mass is much tougher to achieve on wood frame floors. Heating and cooling. Houses that work naturally on their own. When designing these messes, the home will maintain its own temperature. One of the natural methods that's pretty cool is called a cool pipe. The air comes in this end of the cool pipe, if you can see my cursor. If you've got prevailing winds, that's a great way to point it. This is all super site specific, so every site's going to be different. We've even seen these with like the big air vents on ships going up and bringing catcher in the air, and you can spin them around wherever the wind's coming from to get the air in. Often we'll use a fan that pushes the air through from this side or pulls it this way into a rock storage bin or just straight into the house. But you don't want these fans to blow the air too quickly where it won't have a chance to cool off with that nice 54 degrees before it gets in the house. And then you have air vents in the floor or up the walls or somewhere to give you free air conditioning inside. Heat pumps are very commonly used around the area. They used to be so that they didn't work too well when it got very cold. They still don't work very well when it's extremely cold, but the new ones are really efficient and work great for freezing and below. They work great in the Ramona area. A tip is if you install mini split heat pumps in each room of the house. These are great because you don't have to climate control every room in the house in the middle of the night when they're not being used, or any time when they're not being used. They look pretty cool. The inside unit sits above a door or window. They're usually controlled by a remote. There's a small outside compressor unit, and for multiple mini splits, they even make larger compressors that run several inside units. Electrifying homes is going to be really important in the future. We need to eliminate gas since it's so harmful to the atmosphere. Radiant floor heat is great. It's a really nice kind of heat. It's a series of pipes running through a slab supplied with hot water. And if you have a good sustainable hot water source, that's a good way to go. For water heating, basically, again, you want to get rid of your gas and use electric with a timer at night so that It doesn't keep heating while you're asleep. Solar hot water systems are great. Gravity feed hot water circulation systems are something I've done a few of. I don't know if I invented these or not, but they're pretty cool. You have your water supply coming in from the water district or your well. It comes in, goes into your hot water heater and heats up. And from there, it enters your attic at the extreme lowest possible point, and it gradually rises up as it travels through your attic. And of course, it supplies each of the supply points as it goes, makes a loop down, and it's cooler at this point, and returns into the bottom of the hot water tank where it gets reheated and keeps going. And this is great because it moves very slowly. A lot of times when you have a recirculation system for hot water, it'll have a pump and it spins the water around really quickly and it almost cools off by the time it gets to the back. So these are pretty cool systems. They're just hot all the time and you have near instantaneous water at each point. Electrical generation systems. Solar, of course, is the most common around here. The system shown on the right here is a roof-mounted system, which is also most common. This particular one that we did used a microinverter system. There is a microinverter on each panel, which converts the DC power to AC, and several of them are tied together, and then you have individual AC circuits running down to your panel box. The system on the left is a little different. It uses a line inverter, but it uses optimizers on each panel. So it runs DC power, in this case, about 140 feet, to the inverter, which is mounted right next to the panel box. One nice thing about running DC power is you can run smaller wires for the same amperage. The thing about using optimizers or microinverters rather than using a straight line inverter is that with a regular line inverter, if one or two of the panels is shaded, it brings all the rest of the panels in that string, which is several panels connected together, down to the lowest common efficient denominator of those ones that are being shaded. When you have optimizers or microinverters, they all run separately and to their utmost maximum efficiency levels. Wind electric systems are good. There's a few around Ramona. You need to find out if you have a good wind area. We all know about the great big ones as you're leaving town out in the desert, and we're not, but the small ones are usually for individual homes, usually much smaller. You need to get an anemometer to test your site to see if you've got that. Hydropower is wonderful if you've got a river on your property. Not too many of those around here. Geothermal is great if you have some kind of molten lava handy on your property, but those two, not too much around here. Commercial structures. I'm just going to touch on these. Many of these same concepts of residential design can also be used in commercial design. Some of them have partial undergrounding or berming on the sides, which help. They're developing solar collector window coverings. They're not out yet, but they're going to really help because so many of these buildings have so many windows. And it's just a film that can be applied over the windows and actually generate electricity. Operable windows are one of my pet peeves with commercial buildings. You don't see commercial buildings, or very few of them, where the windows open. This means that the central heating and air systems have to run all the time simply to provide air changes. And it just makes no sense to me when we have such a beautiful climate. Commercial buildings, like homes, should also have windows that open. In development are large-scale solar photovoltaic systems for commercial buildings and energy suppliers, utility companies. Also, long-term battery storage options are being developed using other techniques other than lithium. But they're not here yet. They're coming. Now, this next section is about retrofitting existing structures. So all of the standard recommendations that you get in the mail from SDG and even for others include things like updating your weather stripping, replacing your windows to dual glaze, replacing your toilets with low flush, low water usage, change out your lighting fixtures to any energy efficient ones, replacing your old appliances, and adding attic insulation. That's all very important. In addition, other things that can be done, as I mentioned, were solar screens. If you have windows that are just too hot all the time, these can also be treated like storm windows. So you can take them off in the winter and get your heat gain when it's cold, but when it's hot in the summer, it'll block 70, 80, 90% of the sun's heat before it even gets into your house. The reflective barrier on the roof sheathing is important. Use timers on night lighting and other appliances when they don't have to be on. Honeycomb window coverings, insulated, are great. They're on the inside. The heat's already come in, but it still keeps come in through the window, but it keeps a lot of the heat from coming in or the heat from escaping. For very high heat gain windows, we've done things by taking 1.5 or 2-inch polyurethane removable insulation panels or making them out of the 4x8 sheets. It requires taking them in and out by hand, and they don't look good, so we have actually glued fabric on the inside of those sometimes. The problem is it cuts out the view, but it sure helps with keeping your house warmer or cooler if you have windows that you can cut the view out on. If you have electric water heating, make sure you use a timer so that it's not on all night. So it just comes on before the main water use periods. Add solar hot water heating systems. There are different kinds of solar panels that are used with water, and you usually have a larger water heating tank. The old solar hearts use gravity to feed the tanks, which sat above them on the roof, but most of the systems use a pump system and sensors that tell the pump when the water's hot. It spins it around for a few minutes until it cools down again, and then it keeps doing that. And they're very efficient. Replace all your carpeting, wood and vinyl, with Tyler stone for thermal mass, and install the hot water recirc system. Install a cool pipe like I talked about if you have land to do it. High operable windows, as I mentioned, are great because hot air rises. Add as much insulation as possible. It's still the very cheapest thing you can do in all of construction. Plant shade trees to keep all your overall property temperatures down. Add a greenhouse or sunroom. They're great for passive heat gain, but in a community like Ramona, you got to have a way to shut off the hot air coming into the house when it's hot outside. You can find monitors for optimal home energy use. Replace all your gas-powered appliances with electric units. Drive electric cars and fill up with your solar system. And talk to your neighbors about setting up a shared mini microgrid system for electric generation. Sustainable Ramona is working on a microgrid for our community. Wouldn't it be nice to wean ourselves off of SDG&E? So these are the very 6 most effective items that I've found for green home energy efficiency: thermal mass, the reflective barriers, insulation, optimum overhangs, dual glazed windows as a minimum. And finally, when you've done all of that, you add your solar system. So I hope this has helped to understand a few of the many ways that we can utilize age-old building techniques, much of it using the concepts of hot water and hot air rise, in designing and building our new and existing homes and buildings. And now, how about some questions and comments? So Joyce, you may have to be the one that turns everybody on here.
No, they can do it. Rob, I did have a question.
Okay.
And I'm a little confused about heat pumps versus mini split. I thought they were mutually exclusive, but you were implied in your just now in your discussion that you can use them together. And also, I understand that heat pumps have to be in an electric house, right? That's correct. You can't have a heat pump if your system is gas heated or propane heated. Is that right? Did I hear all that correctly?
Well, firstly, regular heat pumps and mini splits are basically exactly the same animal. Regular heat pumps are generally whole house systems. So a lot of the homes have some sort of large air conditioning unit outside for a whole house system. A heat pump has the same thing, except the air handler on the inside is a little different. And when it heats, it uses the outside compressor as well and works on the process of reverse refrigeration. And what was the second part of your question?
That they are complementary, not, they don't, I mean, in other words, you can use a mini split along with a heat pump.
Yes, I happen to have one in every bedroom, a mini split. And I have a much larger 5-ton unit for the main portion of my house,
Okay.
which we leave off all night long and we turn it on in the morning. There's no sense in heating or cooling the house when you're not, portions of the house you're not in there. Our kids are grown and gone, so we use one mini split at night. And so we use 1 out of 4 heat pumps. So it's a very efficient way to go. And heat pumps are getting more and more efficient and cheaper to operate compared with the gas, especially in Ramona when you need to run on propane.
Okay, and then I had another question about solar screens for windows, and remember, I'm coming from a very novice perspective here. I'm almost understand what you're talking about, but where can we purchase such a thing, and how do we put them on our windows?
Well, I don't want to advertise for anybody, but I have a friend in Ramona named Joff Torpin, and for years and years he's had a screen service called Torpin Screen Service, and they come and make specific custom-made solar screens specifically for your window, and they're great. And like I say, you can remove them in the wintertime and store them in your garage or somewhere when you want the sun to come in the windows, and then put them back up when it starts to get hot again. But there are many other companies that also can make solar screens. They're generally made specifically for each individual window because all windows are of a little different size.
Okay, so they would it be a special service just for solar screens, or could you get it at a hardware store, or?
Probably somebody you have to call a screen company that makes solar screens, and I would imagine most of them do.
Okay.
And of course, you need to cover, with a regular screen on a window, it covers the operable sliding sash of the window. If it's a standard EXO window horizontal slider, you need to make double that much with solar screens. You want to remove the existing screen and then put the large solar screen or 2 different solar screens over that window, because if you have 2 screens, it'll really cut out your view. Solar screens will diminish the viewability slightly, but they are so worth it because it keeps your house so much cooler.
It seems like an easy thing to do to.
Yes.
Okay. Sorry, I didn't mean to take up all the time.
No problem. Anyone else?
Hey, Rob, can you hear me?
Yes. Hey, Frank. Hi.
Oh, hi. Yeah, I didn't know you could hear me. Anyways, I just texted you a note, but I'll ask you since I know you can hear them. This information you put out here right here, is it available? Like you have copies of this, or is there a website where it can be viewed?
Yes, you're looking at it. sustainableramona.com. And Walt is recording this and he will post it on the website. I'm not sure if he can do it by tomorrow, but it will be happening very soon. So
Okay.
the whole presentation will be there, as well as the one for tomorrow, Wednesday, and Thursday nights.
Okay.
So it's a 4-night series we're doing.
Sustainableramona.com, right?
Right.
Thanks.
Anyone else have any comments or questions?
This is Larry. All right, can you hear me?
Yes, I can hear you.
Okay, so one of the things I'm looking at is we have 2 windows that most of our house has flow that goes from west to east or east to west, whichever you want to call it. And so we get the ocean flow through the house for most of the house. But because of the 2 windows that are to the south, I'm trying to figure out a way to get that flow to go in it because we can't get a direct flow through those windows. Would it be better to go kind of like your cool tube, but to bring it in from outside underneath to come up into the building to bring the wind and to bring that cool cool air in through that, or better to come up over the top and then come down through the roof to bring cool air into the rooms?
Generally, it's always better, I think, to on a hot day, if you're bringing cool air in, to try and get it as low as possible. And of course, if you can actually have the capability of installing a cool pipe, that brings all that 54 degrees super cold air, because it's always that temperature 6 feet deep around here. It's you're gonna have a backhoe and it's labor intensive to put that in, and then a lot of times you can put a rock storage bin, because that cold air, it's not going to be as cold if you're just using the cold air coming right into the house. But if you can send it into the rock storage bin, that cools down the entire rock storage bin, and then bin slowly gives off its cool heat as the rock storage itself gets replenished through the cool pipe. But it's a bigger project, of course, and always you want to just do the old manual trick of keeping your windows open in the early part of the day and at night when it's hot, and letting the cool air come in and cool your house. And then as it starts to heat up, start closing all your windows.
Okay, I mean, another, adding splits would also be another way of adding, because we have a heat pump but we don't normally use it because we have this airflow through from the ocean.
Right.
But splits might be another way to pick up those two rooms.
Absolutely. And they're really efficient.
That
you're not going to find a mini split unless it's a huge one that requires more than a 220 or a 240 volt 20 amp circuit. And typically a lot of times they'll use 6, 7, 8 amps. So they don't use a lot of juice. They're very efficient. The energy efficient ratings on those things are up as high as 20. And what's much more efficient about it than a regular whole house system of any kind is you have no heat loss through ductworks, because there are no ducts. So that's a pretty cool aspect of it.
And you didn't clean the toilet, your cop out of the toilet.
Okay, thank you.
You bet.
Hi, Rob. Bob Maycomber here. How are you doing?
Great, Bob. How are you?
Good presentation tonight. I'd like to get on the recording here for everybody's sake in the future about one of the mistakes we made with our house when we were building it. We were very careful with our roof overhangs and with our concrete floors and our windows so that we could take advantage of the thermal mass that you mentions that's so important. However, and we did all that correctly, but when we were finishing our landscaping, we decided we needed some hard surface sidewalks and whatnot around outside, some tall doors, sliding doors. And so we poured concrete, and we didn't put in an insulating layer between the concrete and the cement floor. So that essentially rendered our overhangs ineffective, because they didn't cover the concrete sidewalk outside. And of course, the heat that got generated into the sidewalk got transmitted right into the floor.
Exactly.
So I would recommend to people that they don't make that kind of a mistake. That was a simple thing that we could have fixed. We still could fix it by cutting the concrete and putting an insulative layer in between there. But that was just one little mistake that among many that we made.
That insulating barrier you're talking about is commonly referred to as a thermal break, so that it disrupts the heat transfer. But you're right, regular concrete outside, even though it's somewhat reflective because it's lighter rather than darker, it's going to heat up in the sun. There are other options, of course, different types besides concrete of walking surfaces, but there's also coolcrete, which there are types of concrete that you can use that don't heat up as much. But probably that insulating barrier is important, or keep a small strip of landscaping, maybe as low as 6 inches or a foot wide between the house and the sidewalk. I've done some of those sometimes and with the use of gravel. So between the concrete and the house, you use gravel and you don't get that solid heat transfer that way.
That would be good. And we've gone ahead and somewhat mitigated the situation by taking some old rugs that we've found that have been discarded and just laying them down outside on the sidewalks, and that basically absorbs or keeps most of the heat from getting onto the sidewalk.
You know, in the summer around here, the top foot or so of earth will get pretty warm. And it's always a good idea. In fact, the original Title 24 codes required this. When you poured a new slab, you had to have an insulation barrier between the slab and the earth. It's really it's a hard thing to keep in one piece. And they're really troublesome, but if you can get creative and figure out a way to do that, insulating the top vertical portions of the slabs down through the upper portion of the footing is really a good way to go, because that keeps your slab from warming up on the edges.
Yeah. Well, thermal mass, your point there is well taken. That is an amazing phenomenon.
You know, I've been building what are now known as green homes, I guess, since the late 70s. I built the first couple, I think, over on the corner of 3rd and D. And they were green in that we used 2x6 and R19 insulation and R38 ceilings and dual glazing when nobody else was doing that. And a couple of them were spec homes. And the total price was like back then about $1,200 to $1,500 more. And people wouldn't buy them, but they weren't thinking of what they were going to save with energy bills, and they'd pay for themselves. In the case of one fellow that I kept up with that did buy that, in less than a year, it paid for the additional cost of what a regular house exactly like it would have cost, quote, normal. And so I've been doing this for quite a while, and I like to keep up with folks that I've built homes for. And it's a good way to go. And of course, I've always called it energy efficient design and construction. Green homes is what they're called now, along with using green manufacturing techniques, which is very important. But our planet is in such a state that we all need to pay attention to this. And retrofitting existing homes is very important. And one other thing I think I mentioned, new construction in fire areas, I think going underground or at least semi-subterranean is going to become more and more important, simply because they don't burn if they're burned with earth or rocks or underground. So as long as you have a non-combustible roofing material or an earthen material for your ceilings or your roofs. So if I was younger and wanting to revitalize my business, I would be heading that direction. I've always tried to design an above ground cave because they simply work. This temperature inside is very stable and requires very little of any kind of energy to maintain a comfortable temperature. The underground garage I built that was about 900 square feet makes a perfect cave for a winery. The temperature is just so wonderful in there all the time. I was really impressed with the cave that is at Milagro. The Ramona Mural Group had their first festival there, and I got to tour that cave, and it's just so wonderful inside. The temperature stays perfect all the time. So our next series, Joyce, is that going to be next month or the month after?
February.
February. Oh, so that's going to be on transportation. And boy, that's another area where a lot of strides are being made right now. My wife and I are going to be test driving an electric car tomorrow.
Oh, cool.
So we're getting close, but if you can do these things, if you can have a sustainable home, using some of the techniques I've gone over, and create your own power and drive electric vehicles, then you're going to be really close to a negative carbon footprint. And that's what we need more and more folks to do. I'm probably preaching to that choir here, but it'll happen slowly. I spent a lot of frustrating years because nobody was paying any attention to any of it. And now more and more people are. So that's very good.
Rob, I got another question for you.
Sure.
We were wondering about cool paints and cool roofs. Painting your roof white. I was just reading a report the other day about a couple of universities that have developed new white paints that reflect 98% of the incident radiation. And because of all that reflection, they actually maintain a cooler temperature than the surroundings, which is almost as though they're air conditioned. I don't think those paints are available yet commercially. Have you heard of any place that may sell them? We're outfitting a camper van, and I'd like to paint the roof with that paint. Do you know anything about that?
Only that I've heard about it and that it's coming. I don't know much more about it than that, but they're also developing a paint that you can put on the exterior of your home that gives you, for every layer of paint, like an R 1.5 or 1.2 R value of insulation. So there is some wonderful technology in the wings. I haven't heard that either of those two items are available yet, but it makes me feel good that it's coming. There's a lot of cool things that are on the way.
One of the things that we do typically in this part of the country is use tile on roofs, and the tile absorbs all that energy during the day. And because it has a high thermal mass, it then begins to emit that energy after the sun goes down. And that's even worse for the greenhouse effect. Whereas a metal roof doesn't have very much thermal mass, it's just a thin layer of metal. And as soon as the sun goes down, it cools almost instantly because it's not stored very much energy. So I wonder, what do you think about the thermal mass on roofs?
Well, your point is well taken that thermal mass on a roof is probably going to give off heat at some point that it absorbs during the day. It'll probably give it off in the evening, and that's probably the negative. But in my experience, with virtually any kind of roofing surface, even if it's a very, very dark roof, if you apply that radiant barrier on the bottom of your plywood and you have what I call insane amounts of insulation, it doesn't matter too much as far as the ambient air temperature inside the house. It's not going to matter. That radiant barrier is going to bounce that heat right out, and the insulation is just going to create that above ground cave along with whatever thermal mass you can muster up. But it is a potential problem that we're warming the atmosphere with a thermal mass heavy roof. I have both styles. I have standing seam metal, and I actually live in an adobe house, and it's a hacienda style, so it has clay tiles on it. But clay or concrete or any heavy roofing material might have the tendency to release heat back into the atmosphere at night. I was involved in putting a new roofing surface on the Leslie's pool supply building at 1905 Main Street a year or two ago, and that was kind of a cool thing. It's if you have most of these commercial buildings have a flat roof, and there'll be generally a torch down system is used these days. It's like a rolled roofing, but it's slightly different. But This comes, you can get it at Home Depot, and it's a paint. I mean, it's like a paint, but it's a roof surface, and you roll it on, and it's pretty bright white and reflective. And I was just amazed at how inexpensive it was. But I don't know that it's giving you, it's giving reflection, the reflective values. I don't know if it's as much as what you're talking about, but it's actually made by Henry's, I believe. So, Bob, you might check into that. And if you shoot me an email, I can give you the blurb on somewhere. I've got the nomenclature on exactly what that is, and it's not that expensive to buy.
Cool. Yeah, no, my point was more the thermal mass question on roof materials, because when the energy is stored up during the day from the sun, and there's a lot of thermal mass on the roof, the material itself, as soon as the sun goes down, it begins to emit, and emitted radiation is a different wavelength, and it can't get out of our atmosphere. So it's a whole different kind of a physical situation. So I think we should look further for standing seam metal roofs, or any kind of a roof that reflects the heat in the first place, so that you don't build it up and store it up and then re-emit it at night.
I have a place up in the mountains in heavy snow country, and I have a standing seam metal roof with a steep pitch, and that's great. And I have a studio here in Ramona with a standing seam metal roof, also great, even in a hot climate. And one nice thing about both of those situations are they're basically fireproof. I mean, if something crashes down on it, puts a hole in it, it's getting down into the wood portions below. But generally, if a tumbleweed that's on a fire falls, blows up on the roof, it's not gonna set you on fire like maybe comp shingles might melt. Tile's good for fires as well, but I had a house destroyed in the '07 fires, and it had concrete tiles, and they just crumbled. Of course, the fireman said that the temperature got up to about 2,800 degrees, and nothing's going to make it through that.
Well, of course, that was after the fire got inside the house. Here's another concept that we're probably going to need to consider more as we adapt to climate change, and that is our drier, warmer climate in Ramona may be susceptible to more wildfires. And of course, the insurance companies are very, very gun shy right now about insuring us out here as it is. What do you think about Sustainable Ramona coming up with a series of concepts in building or refitting houses that the insurance companies would recognize and maybe be willing to insure our houses, or some of them that they might otherwise say, no, you're in an uninsurable area, whereas our house may be totally fire resistant and certainly be insurable. What do you think of that?
I love it. And, I go immediately to, you saw the images of the underground garage I built. There's no way that's going to catch on fire. There's nothing that would burn anywhere in the building. It's all solid rocks or dirt. I did put a couple of windows in, but I've thought about making some, I've done this up north at my place. I've taken hardy panels, which are basically concrete plywood, as shutters over all the windows, and we put those on every time we leave. Because I think my house burnt down in '07 because a 1 or 2 pound burning ember was blowing horizontally through my windows. The winds were up gusting way over 100 miles an hour. And those kind of things, only an insurance company is going to feel a lot better about something like that than they would a quote normal constructed house.
Right. So I think that could be part of our website here at Sustainable Ramona, is for people to consider, as you mentioned, shutters on the windward side, and something about the material that the roof is made out of that's resistant to fire. A metal roof, as you said, is not going to catch on fire.
I agree. So Joyce, we've come up on 7:30. If does anyone else have any parting shots here tonight? Well, thanks everyone, and we've got another one tomorrow night at 6:30 with Steve.
Great. Thanks for all the information, Rob. It was really informative.
You bet, Lynn. And this, like I said, this will be available if you on the website if you want to download the video. Walt up there in the left-hand corner will be posting it up on our website.
Thank you, Walt.
Go Walt.
Okay. Marianne, Greg, thanks for coming. You haven't talked, but I see you there.
Thanks,
So,
Rob.
all righty.
Thanks, Rob. Good presentation.
Thank you very much. And we'll do it again tomorrow night.
Thanks all. Good night.
Okay, thanks, everybody.